I'm curious. Those viaducts in the sky, how is it built? Today, we will take a look at the tallest viaduct in France. That's how the Pomerleau Viaduct was built. The highest height of the Pomerleau Viaduct reaches 343 meters. This is comparable to the Eiffel Tower in France, 43 meters higher. Its total span is 2.5 kilometers. But it is supported by only 7 pillars. The completion of this bridge is an engineering marvel. Because it is located in the Tourne Valley in the south of France, the climate here is changeable. The wind is strong. Wind speeds of 200 kilometers per hour are frequent, and the address conditions are complicated. To build, can withstand such a high pillar, and the stable foundation of the bridge. It's very challenging. After a detailed geological survey, the engineer start laying the foundation at the designated location. For the stability of the foundation, must find solid rock that can withstand tremendous weight. The floor was finally found after a full 15 meters of digging. In order to have a stronger connection with the rock formation, the engineers first drilled holes in the bedrock, after inserting steel pipes and steel structures. Refilled concrete. So this is the result. For pillars saturated with bedrock, then you can build a foundation on top of that. We start with a 4-meter high jade frame. Again, within the framework, build a highly dense grid of private rooms. Wait 1 to 2 days for concrete to solidify after pouring. Lift the frame again. Continue to add steel structures, and pour the concrete again. Do it over and over again, until the entire infrastructure is completed. When the foundation is completed, next comes the construction of the main pillar, and this process uses a self-climbing frame, building steel skeletons and plastic column concrete layer by layer. As the height of the pillars increases, the engineers set up tower cranes on the pillars, machine general worker. Equipment and concrete materials are transported to high places. When building to 2/3, the pillar is divided into 2 parts. The benefits of this design. One is to prevent high winds from damaging the pillars, and then for a more even distribution of echo during the construction of the pillars, to make pillars hundreds of meters high. It's perfectly vertical. Engineers used millimeters and precision GPS positioning device. This causes the final strut to be misplaced. It's to 2-3 millimeters. Just like this, 7 pillars of different heights. Finally, all construction is completed. But the real challenge is just beginning. Due to the distance between each pillar being 350 meters, the concrete blocks are not large enough to support such a large span. So the engineers finally decided, use steel modules instead. But if on the ground, prefabricated middle bridges this long, that weighs tens of thousands of tons. Not to mention that there is no such a big crane, even though oil might have broken the pillar. Finally, the engineers came up with a solution. They chose to be on either side of the bridge. On-site welding of steel bridge foam 1 by 1. And we use the hydraulics. Move the bridge forward little by little, until the final docking is completed. To avoid modules collapse between long-distance pillars, engineers are among the pillars, and we built support systems. There is also a sliding mechanism installed on the bridge tower. But even so, because the bridge is too heavy, too much lateral friction on the struts, it will also be pushed to the pillar with serious consequences. So finally the engineers decided, install all the struts as hydraulic movers. Set each device to cooperate every time. Push the bridge forward together. His working process is like this. But because the span between the pillars is too large, so for the stability of the bridge, and put caps and cables on the struts. Tower cap height 90 meters. The steel cable also weighs 700 tons. But these are relatively easy. Finally, the bridge is connected little by little. The docking error is only 1 centimeter. The entire bridge is made of 36,000 tons of steel. The Pomerleau Viaduct overcomes the height, climate, geology, and other problems. Its majestic structure and superb design. It has become a benchmark in the field of bridge engineering in the world. However, in front of our infrastructure fanatics, the younger brother,